Good day, ladies and gents. Today we are talking about basic dimensioning. Now, after this unit, you should be able to dimension basic parts according to engineering standards. So a couple of the goals today. 1. You should be able to understand basic dimensions when looking at any technical drawing. 2. Apply basic dimensions according to engineering standards. 3. Be able to identify basic terminology, dimension line, extension line, reference dimensions, and leader lines. 4. Be able to identify 4 basic common machined hole types: countersunk, counterdrilled, spot-faced, and counterbored holes. When dimensioning anything, the whole point is to clearly communicate the part. So we use a terminology and a basic language when doing so. If your goal was to make this part, it is essential that you give all the dimensions necessary, not only to know the sizes of the part, but what materials it's going to be made out of, any special treatment this alloy needs to be treated with, and then also any special features where if this is my datum, the reference edge that I need to reference for all of it, or the center axis, that is essential to notate on your sheet or your technical drawing. Since the whole point is to manufacture this part, it's important to concisely give all that information. So essentially get rid of everything that's not needed, all the redundancies, any of the clutter, and only break it down to what is essential to make this part. So let's dive into it. The most important is the dimension line, which actually shows the arrow and pointing to the extension. Inside the dimension line, you'll have the actual number, which is the dimension itself. Those arrows point to the extension line, which are very thin lines that go all the way to the part or to the reference that you are dimensioning. Then you have a leader dimension, which is commonly used for diameters and arcs, but are also used for other notation. Arrowheads are on the ends of all dimension lines and can be represented in different ways or different directions depending on how much room you have. There's also something very specific about the gap between the extension line and the actual object. This is called our extension line gap. And then there's also an extension that goes past the last dimension in order of dimensions. When dimensioning your part, you should have a no dimension zone, which is 3/8 away from the part. If your text is 1/8 of an inch, you know that it's 3 text heights away from your part at all times. Dimension spacing, the first dimension away from your part should be 3/8 away, just like we said previously. However, the consecutive dimensions after that, they should each be 1/4 inch away from that first dimension or from the previous dimension. Your arrowhead should typically be 3 times longer than they are tall. I tell you to use your A stencil in your lettering stencil guide. So that's your little green stencil, and just turn it sideways and use the capital letter A. So with all of our dimension rules, as part of the engineering handbook, this is the largest section of information that you'll actually go over. I'm going to simplify it down into these 21 steps for you to start to utilize in your drawings. The first step, Step 1, avoid placing dimensions on the part. You should always extend the dimensions off the part, especially when possible. There might be several instances where you have to break this rule, but at all times, keep your dimensions off the part. Step 2, you want to avoid dimensioning to hidden features. You have the option to present different views of your object. So give the dimension in the view that describes the object best. That means not a hidden feature. Step 3, always place dimensions where the characteristic shape is shown in the most descriptive view. This goes basically with step 2. If it's most descriptive, it shouldn't be hidden. Step 4, dimension holes in their circular view with a diameter. Specify special features, hole types with a note. So, if you're dimensioning a circle, you should see it as a circle and not as a hidden feature. Step 5, dimension rounded corners and arc features as radii, where they appear in their rounded views. This goes with the other 4 previous rules. If you have a radius, you should dimension it in the view that shows it to you as an arc. Step 6, if the same value is repeated many times, then use a general note for the feature. For an example, looking at this fillet on the left-hand side of our shape, the radius is 0.2, and so in parentheses after the dimension, you'll put TYP, which means typical. You'll also see this with hole diameters. If you have a consistent hole type, instead of giving a TYP, you actually want to specify the number of holes. So you would put the number, let's say 5, with an X after it, and the diameter symbol. Rule 7. Dimension cylinders in their rectangular view with a diameter symbol. As you can see here, we're going to dimension this cylinder in its side view. So that's different than holes where you dimension them in the front view. You want to dimension them where you see the height of the cylinder and then you give a diameter symbol in front of that dimension so I know it's a cylinder. Step 8, we've kind of mentioned, you want to make sure your first dimension is 3/8 away from your part. In metric, that's 10 millimeters, and then every consecutive dimension after that is a quarter inch away. So if you're looking at this part right here, this 0.6 is 3/8 away from the part, and then the 1.3 is 1/4 away from that first dimension. Rule number 9, keep dimensions between views whenever possible. We typically have been giving a 1-inch space between our views, however this will increase as you have more details and need to give more dimensions. So between these two views, we have 1.6 and 3.6. It's between the top view and the front view. Instead of giving it like this, where this information is harder to track across the different views. Rule number 10, dimension lines should never be crossed. Extension lines may cross each other and over other lines on the part. So hint, no arrow-headed line, that's the dimension line, should be crossed with another arrow-headed line. If you're looking at these examples here, notice this extension line can go through this extension line as well. However, you should never have this happening. You should never actually use an arrow-headed line, a dimension line, and cross another one. What that means is your larger dimensions will be further away from your object. Rule number 11, the overall dimension should always be given. Like I said in the previous rule, it will be furthest away from the object. However, when deciding which dimensions are redundant, you always want to make sure the overall dimension should remain. So when deciding that some of these dimensions are not necessary, eliminate one of the smaller dimensions, not the overall. Rule number 12, do not duplicate dimensions and avoid using unnecessary or superfluous dimensions. So that redundancy, if you're looking at these examples here, I don't need this 0.5 because I can figure out this dimension because I know the overall, which is always necessary, and I can subtract the 0.6 and the 0.5 from 1.6 to know that this is 0.5. I can do the same for the height. I don't need this height because this is a right side view and I've given height in this view. So between the different views, it's very easy to give redundant dimensions. So before you say this drawing is complete, go back through and review what information you've actually given and simplify. Rule number 13, when all the dimensions are expressed as inches, do not use the inch marks or the abbreviation IN. So that will be stated in your title block. You don't need to write it after every number. That would just be a lot more work for you. Plus, we're trying to simplify it down and make it easier to read. For drawings dimensioned in inches, values less than 1 inch should not be preceded with a 0. As you can see in the dimensions, you should not have these zeros before your inches. For metric, however, you should include the 0. So for inches, do not include a 0.70, but for metric, you should. This is another identifier when determining your units of measurement. Rule number 16. For metric drawings, omit the use of the millimeter mm notation following the numeral. So just like inches, we're not going to specify for every dimension what unit is used. This will be specified in our title block. Rule number 17. The origin for baseline or ordinate dimensions used as a datum should be extended from a finished edge of the part. So we are going to be using baseline dimensioning in this class. Chain dimensioning you want to avoid. The main reason is because it increases the amount of tolerance as you go. So let's just say our first dimension is off 0.001. However, every dimension after that will also be off 0.001. If you use a datum, which is essentially a perfect zero or a flat surface on your part, every dimension has its ability to be to that 0.001 tolerance. So you're minimizing the amount of error in your dimensioning. It's also easier to track what dimensions you have left out and what you still need to include. So we are going to be using baseline dimensioning, not chain. Rule number 18, conserve space and time by using these abbreviations and standardized symbols whenever possible. I'll be giving you examples of each use of these, but take a snapshot of this list right here and know them by memory. Rule 19, reference dimensions are placed in parentheses, or they should include the abbreviations REF. Basic sizes to be tolerance should be placed inside of a rectangular box. So two things going on here. You'll notice in your CAD package that certain dimensions will be grayed out or have parentheses around them. That means that your object is over-constrained or over-defined. However, it's important, if you've included it, you're saying that it's important to still know. The boxed-in dimension is a basic size to be tolerance to. That means if you're adding tolerance, this is the dimension that you should start with. So that way all the other tolerances are referencing it. It kind of acts with your datum. Rule number 20, extend leaders from the first or last word in a note. Point them toward, but do not touch the center of the circular features that they are specifying. Notice the angle of the leader line here. If you were to follow this angle all the way to the center of the circle, it would hit bullseye. Same with this one. So the angle changes depending on the location of that leader. If you followed this one, we are totally missing the bullseye. It's still pointing toward the arc, but it's not referencing or pointing towards the center of that arc. This is another bad example. 21. Place dimensions among the various views to avoid crowding. Stagger horizontal dimensions to avoid contact or crowding of the values. So if you're looking for the difference between these two examples, notice how the numbers or the dimensions themselves have been pushed apart. This one is closer to the top arrow. This one's closer to the middle. This one is exactly in the middle. They don't always have to be perfectly centered within the dimension line itself. Stagger them so they're easier to read. Remember, this is all about clear communication. So those are our 21 rules. Now here are a couple other notes. Angular features. Dimension angular features with these two methods. You can either use an XY coordinate location, where you're basically plotting the endpoints of each of your angles and referencing their height and location, or width and location. Or you could use a vertex location and degrees. So you're plotting or referencing where this point is, left to right, or right to left, and then you're giving the angle of that feature, so 39 degrees, versus the location of both points of that angle. Dimension styles. Unidirectional dimension read from the lower left corner of the sheet. Align dimensions align with individual dimension lines. We are not going to be using aligned dimensions. We are only going to be using unidirectional. That means if you're looking at your drawing, you should be able to read the dimensions without turning your page. The numbers are always horizontal. Let's take a look at our different holes. A spot face hole is a very shallow countersink hole, essentially. So no depth required, cleans an uneven surface depth enough to allow full contact with bolt or washer. So what you have is, this is the top view, this is the side view, and you can see there are two diameters, and the spot face is usually just a standard depth. So we have the larger diameter that goes this depth here, so that is a diameter of 1, and then we have a through diameter that is 0.5. So this is the way you should write that, with a diameter symbol, 0.5 through, comma, SF for spot face with a diameter of 1, or whatever the diameter would be. A counterbore hole is very similar, however it's required to have a diameter and a depth dimension. So very similar to the counter spot faced hole, you have this small diameter with a notation that goes all the way through, and then you can have a CB or a symbol that looks like a field goal post, and you give that diameter next. Then you need a depth. The depth references the depth of this larger hole or diameter. That can be given to you as a DP or this depth symbol here. Counter-drilled holes require a diameter and a depth dimension. This is measured to the shoulder. So like the counterbore hole, you're going to give all this information, however you're going to notate that it is a counter-drilled hole instead, because it's measured to the shoulder and it has this slight angle inside the hole itself. A countersunk hole gives the small through diameter. Then it has a CSX, or this symbol here. Then it gives you the larger diameter with the angle of the countersink. These are used with flathead screws and bolts. They become flush when tightened, used extensively in aerospace industry. The 82 angle is common for cutting tools and screw threads. So if you went to your local hardware store and bought a countersunk drill bit, this would be the standard angle you would get. Chamfers are another detail that you'll see on a lot of technical drawings, and also you might just see it on a lot of parts that you interact with on a daily basis. You break away sharp edges and to help guide the part into a mating assembly. They may be specified with one distance and one angle, or with two distances. So if it's not a 45-degree chamfer, you'll see two different distances given to you, measuring from the 90-degree corner. Next are used for O-ring seals, parts turned on lathes and design failure points. So you'll see these little areas added to mechanical parts. This fits a silicone or rubber O-ring that usually basically makes parts airtight as they're sliding through a shaft. Knurling is a process of rolling patterns into cylindrical objects to make them easier to grip. When dimensioning in small places, you can have a series of different ways to reference these dimensions. Notice some of these different options here. The point 1, the arrows are facing inwards and the numbers on the outside. This very small 0.05 dimension, you can see is just pointing down to it, almost like a leader with a dimension above it. The 0.4 dimension is the arrows pointing from the outside with the number in the middle of those two extension lines. You'll also see this 0.2 and 0.3 to the right, with both extension lines pointing in and the dimension number right in between the extension lines. Then for repeated details, you can also have this 0.10 slot with the different leaders pointing to each of those features. For repetitive features, there are different ways to do this. So typically for radiuses, I'm going to say give the R symbol, the number, and then TYP for typical in parentheses. When dimensioning multiple holes, give the number of holes with an X, and then the diameter with the measurement. Let's put this to practice and dimension a simple object. I like to break it down into 3 simple steps. First, give the overall dimensions of the object, that's height, width, and depth. Then identify the location of certain features. Lastly, give the size dimension of those features. So we're going to be dimensioning this object. We have our front, top, right, and our isometric view. We'll mostly be focusing on the front, but let's go ahead and go through our dimensioning guide with our 3 simple steps. So first off is giving the overall dimensions. With any 2-dimensional drawing, you only have 2 dimensions in each view. So in my front view, I have the overall width, and one of those rules is to place the dimensions between the 2 views. So I don't want to place my width down here because width is also shared with the top view. You can see it projects straight up. So I'm going to place my width somewhere between the 2 views. The same goes for the height. So if I give the height, I'm going to place it between the 2 views that share height. I also have depth, which would be in one of my other 2 views, either side or top. I'll just place it over here for now. Now let's focus in on the front view. For this, I'm going to start by just roughing out the dimensions and going through what's required. So the next rule is to identify the location. Tell where the details of the object are. Describe negative shapes, negative masses, or features in this object. So as I come across, I see this notch. I need to show where that is in location to one of the sides or references. I'm going to reference this side as my 0, or what's known as your datum. So that notch is 1 inch from that edge. I also need to show the location of this circle or this hole. And I also need to show where this angle is, which is 4 inches. I'm just roughing this out for now. I'm going to be coming back in here and organizing these dimensions later. I also have some locations in reference to the bottom edge or the vertical location. So I know that this hole, let me redo that, is 1 inch from the bottom. And if I'm doing an ordinate dimension for this angle, that angle is 2 inches from the bottom. The last step in our dimensioning guide is to identify the size dimensions. So tell how large the details are. So this negative mass is, well, it's 1 inch wide. This would be a chain dimension. I don't want to do that. So to show the size, I'm actually just going to give another dimension right here, which is 2. Then I need a size of this diameter, 1.25. And since I have 2 ordinate dimensions of the angle, I don't need a size of it. But let's say I didn't have that. I could give the size of this angle by selecting the line and then also referencing another line to give the angle. All right, coming back through, I have all of my overall dimensions done. I have all of my location dimensions. And then I have the size dimensions of each of these features, except I don't have the size of the depth of this notch. So I would need to show how deep that actually comes into the shape. So always go back over and look through if you have everything. If you couldn't 3D model or manufacture this, you must be missing something. So let's organize this mess of dimensions. First off, you should never have any dimensions on the actual part. So I'm going to move this dimension somewhere down here. I want to try to keep my dimensions close to the actual feature. So I'm going to move this 3 down to the bottom of my view. And I'm going to move this 45. Now that I have my dimensions where I think they belong, I'm going to organize them in the correct proximity to my object. So there should not be a single dimension that is within 3/8 of my object. I have to pull all of these dimensions away 3/8. I can't actually tell that using the program I'm using right now, so that's why I use that reference. If my text or my letter height is 3/8, it should be 3 heights or 3 letters away from my object. So I'm going to get as close as I can, and then I'm going to make sure all consecutive dimensions are 1/4 away from the consecutive text. And remember, those numbers, those dimensions, they don't have to be right in the middle of the dimension line. So I'm going to stagger those numbers so it's super easy to read. This 35 needs pulled away. And there you have it. This is fully dimensioned. I'm looking back through to make sure I'm following all of my dimensioning rules, and it looks good. Now I'm going to show you a really simple way. It's best to know what you plan on doing before you start your dimensions. But if I know what I actually need, I can come back in here and use baseline dimensioning from the get-go. So baseline dimensioning, remember, it's referencing one point of your object or one datum. I know that I'm going to be referencing this left side for all of my widths. So I'm going to be using a baseline dimensioning tool. And this is how I like to think to make sure I don't forget any of my dimensions. I just like to work my way left to right. So I have my 1. I come to the next corner or feature. I now have 2. I come to the next thing, which is the center point of my circle, which is 3. Come to the angle. And then I get my overall. So I just gave all overall dimensions and all location dimensions, and I even gave the size of that width of the notch. I'm going to do the same thing for all of my vertical or height dimensions. I first need to start with something that references the baseline. So that first dimension should be 3/8 away. And then I'm just going to work my way up from the bottom to the next feature, which is the bottom of this notch, or to the angle. They happen to be the same, so I'm going to choose the one that's further away so the extension goes through that part and also identifies it. And then the overall height. I only need one more thing, which is the size of that diameter. I'm going to go ahead and place that below here. And now I have real clean baseline dimensions. Now you could make the argument that this 3 would make more sense to have below because it's closer to the circle or to its feature that's referencing at the bottom. But I would just need to pull these down so that way they are at the right distance from the previous dimension. Same goes for this 2. You could make the argument it makes more sense to be on this side because it's closer to what it's actually referencing on the left. And then I would just move this 3 in. That's very similar to what I had previously, but by working my way left to right, I'm ensuring that I'm not forgetting any of the details that are required with this part. Good luck!